Welcome everybody for joining this session. We're going to be talking today about edge computing. I'm joined by Marcus Dornan from Rahi and Koroush Saraf from ZPE. My name is Michael McDonnell from the Business School in University College Dublin. I'll be moderating today's session and start off with a very basic question. Edge computing obviously is a large field which combines some technical aspects of hardware, software, business applications. Could I maybe ask each of you in turn, just to give us a quick summary, if it's not too basic a question, of what is edge computing? What do we understand by the term?
I might go ahead first, Koroush. So I suppose edge can mean many different things to many different, I suppose, people looking at I suppose edge infrastructure. You know, edge could be a standalone IT device, the far side of a city, or it could be a many IT assets in a containerized data center at the far side of the countryside. So edge can mean different things to different people. I suppose when you look at edge, seems to be the more modern name for what was branch, I suppose, as well. What it would be a deployment of an IT application or an IT asset that's performing some type of local function to either speed up the processing power, the collection of data, possibly the storage of data and interrogating that. And I suppose edge basically is everything outside the data center in its most simplistic format, I suppose. So that's probably a simplistic view, but looking forward to Koroush's thoughts on it as well.
Yeah, my answer is actually quite simplistic, because I think edge is actually really a simple concept. It just has to do with distance, right? So if it's just close to you from a user perspective, so I think the perspective matters. You know, edge of where is usually my next question. So edge with respect to the consumer of the information, or where the workload is, and the distance to that where the work is consumed or produced, is really what edge means to me. And there are various reasons why that's important. I think we'll probably get to that next. But you know, I think from a just to start that topic, you know, the reason that this whole edge thing became a thing is because cloud or data centers or things that were more distant weren't cutting it for probably 4 categories of reasons, and we can go into that next.
But I think, yeah, I mean, it's a renaming in effect for what has been there for the last 30 or 40 years anyway. You know, branch remote sites have always had some type of IT infrastructure there, you know, and with the explosion of IoT, I suppose, the processing power, the capability, the requirements now that are on the edge, I suppose, have grown more dramatically in terms of the speed, the resilience, and what they're required to do. But I think edge today is probably a renaming for what branch was. I mean, if we look at maybe the data center environment as well, you know, 20 years ago, we used to call cloud application service providers, and now it's renamed cloud data centers. So it's just another renaming, I think, for what was there. Obviously, the technology has grown exponentially, so it's more of a renaming for what was there for the last 30, 40 years.
And Marcus, to add to that, I think that renaming is because in these technological shifts, you have going to 20 years ago, there was no cloud, there was none of that stuff. Things were either done in a branch or in a data center. And then this cloud thing came about, right? So then everybody's head was in the clouds. And then now it's about, okay, there is something more than a cloud. Let's go back to edge, right? And I think the pendulum keeps swinging too hard in both directions, and it's about bringing people back to not everything can be done in a cloud. You know, don't forget about other locations that things need to be done as well, right? So it's just about, sometimes the hot thing of the day just makes people forget about the rest of the necessities that people have to worry about when delivering services.
Yeah, and 20 or 30 years ago, I suppose you didn't have the connectivity or the bandwidth. So after the day's work was done in the branch or on that remote side, it was stored on tape, then transported in to it.
Now you're going too far back.
Yeah, then back into the warehouse, or what is
Yes.
the data center now? Yeah.
Great. So I guess a question, two things that occurred to me. One is the kind of overlap or intersection between edge and cloud computing, because we, I guess, hear more about cloud computing in an enterprise context these days. But examples that we can think of for edge computing are frequently in private networks, which may have a lot of data, remote data gathering and a lot of IoT applications. And so again, being simplistic, cloud has a role to play within the edge computing domain, but obviously it's not an exact overlap. So there are a lot of edge computing applications that are not or need not be cloud-based.
Yeah, definitely cloud. I mean, cloud and edge go hand in hand because, again, on the remote side or the edge side, that particular application is performing a certain function that's interrogating information, it's processing it, and then it's deciding to maybe decide what needs to be brought back to the cloud to be stored. So they very much work in parallel with each other and symbiotic. So they work in tangent with each other. I think what the edge does sometimes is it determines what is the data that is important to be sent back to the cloud or back to the enterprise data center, and it can interrogate that remotely. And sometimes when you have the infrastructure, the software or hardware at the edge, it can sometimes save on the amount of space or the amount of processing power that you require back in the cloud as well. So it is performing a certain important action, but they work hand in hand with each other,
Right, and different types of organization will obviously have different levels of infrastructure. So I think maybe smaller organizations may go for the convenience, reliability, resilience of cloud services, maybe, where some larger organizations. So to take an example, I think we talked before about oil industry applications, where you may have a large company, a large producer in the oil industry who will obviously have a lot of remote sensing and so on, where they will effectively have fairly full control of a private network with less dependence on cloud services, whereas maybe somebody, let's say, more in a more retail type environment, distributed environment may have a greater dependency on cloud applications. Would that make sense?
Yeah, I mean, if you want my perspective on this, and I'm a product guy, right? And for whoever has worked with me, all of this, all of these answers that I hear in conversations, I always go back to the very, very beginning to really ask, what is the problem that needs to be solved, right? So everything starts from the problem statement and the pain point, right? That's so without the other thing that I usually say in conversations is, let's not solution it, right? Let's define the problem first. and so the problem that really needs to be solved, even with the advent of cloud compute and things in data centers and kind of that shift that has happened in hybrid infrastructure and all these things that have happened, then there's a problem that remains, right? And in fact, there are 5 problems that remain that edge compute is to address. So edge compute is not just IoT, is not anything specific. It basically comes down to what the problem is. And the 5 categories of the problem is that, hey, there's just too much latency to get to the cloud, right? So that's one category. The second one is I just have too much data to send to the cloud and I don't have fat enough pipes, right? So in the oil field example, even up to today, it is more efficient to FedEx tapes, to use your word, Marcus, you reminded me of that, than to actually send the data over internet. So you can FedEx, a petabyte of data from an edge in 24 hours from an oil field to, say, San Jose, where I am. Whereas if you wanted to, send 10 petabytes of data, it would take you years, no matter how fat of a pipe you have, right? So there are still things that FedEx wins with respect to bits traveled per unit time. So bandwidth is one, latency is the other, right? That's two categories. The third one that I come across, and it's one of those Gartner categories as well, is regulation. You just can't send stuff across boundaries. I see that actually quite a bit come up in Asia, where people in Macau say, I just want my stuff in Macau. Now don't ship it anywhere else because all the pipes go through China, as an example, just to bring China into the conversation. And then the fourth one is autonomous operation, right? You just want this thing to be autonomous and not be tethered to anything. One example that I worked on was on cruise ships, right? Cruise ships are, by nature, you don't have fat pipes. Even if you did, it's so expensive. But you want all of your operation to be done locally on the cruise ship. So that's a very good example of autonomous operation and edge compute. And the fifth one is just cost, right? Even if you could solve all of those problems, it just may not make sense to pay those bills because you could do it by magnitudes cheaper if you do it locally. So those are the five problems that edge compute essentially is set to solve.
I think that's
interesting. I think people would be surprised, maybe, particularly that the idea that there is a volume of data where the transfers to the physical transfer of a medium is faster than.
It's still true today.
I think a lot of people were.
Just a specific example is seismic data. So the oil companies do a lot of seismic data collection and to basically figure out what the plates under the ground look like, and it's basically huge amount of high resolution survey data. It actually amounts to petabytes a day, right? And the compute just wasn't available to do it at the edge, so you basically ship it to large facilities, and you pay that FedEx cost. And now with compute becoming more and more available at the edges at those speeds, you can at least do local decisions versus this 48 hours that it takes to go back and forth.
Great, and I think you touched on this already. The idea of regulation, governance, control, security in particular, is a strong argument, obviously, for keeping certain applications private.
Yeah, data sovereignty. That's also very important, obviously, and applicable within the EMEA and GDPR regulation, where Koroush just mentioned there that transfer of data from one sovereign region to another. That's important to kind of keep that within region. So when you're processing that data within the EU or across the EU, you have to be obviously cognizant of what you can and cannot do as well. But I think another big area of edge infrastructure is the management of it. The reason why you have edge is obviously just to be close to your geography or be close to your customers itself. So you're deploying a lot of high-end edge infrastructure a lot of the time to process, store, capture information, and that can be very expensive equipment some of the time. You'll have containerized data centers that could be storing 10 racks of up to 100 servers, for example, and that's got a high-end cost. But the reason why it's out there in the edge is to be close to their customers, and the key thing is there to be able to, how do you manage that infrastructure? You'll have a headquarter based in Dublin, for example, and you'll have distributed sites all across EMEA or globally, and you need to have the right capability and infrastructure to ensure that the mean time to repair that you can get to that asset, you can control it, you can manage it, you can monitor it. That's the other thing that needs to be borne in mind when you're looking at deploying edge infrastructure, is the how do you actually control it? How do you monitor it? How do you interrogate the information that comes from it? So it's important to have some type of also management layer when you're deploying your edge infrastructure as well, kind of a belt and braces approach to ensure that the high-end infrastructure that's doing all the critical work there can also be controlled and managed. And as Koroush mentioned there in the application for an oil rig, where obviously to get there you need to send. Well, today, if you don't have some type of management infrastructure in place, if you want to get an IT expert out on site, well, you have to get them there in a helicopter. There's a cost to that IT infrastructure being down. That oil company can put a cost to that asset being down, or that edge infrastructure being down for an hour, for 2 hours, or a day. So to have some type of IT infrastructure there that allow you to get in through a back door via LTE or some other kind of belt and braces approach, that's also important to ensure that you have that as part of your edge, I suppose, strategy as well going forward.
Yeah, just if I can stay on the security question for a minute, we've seen a couple of very high profile examples recently of things being accessible on the internet where maybe they shouldn't have been. So we had one in the US in the oil industry, and then a data breach in Ireland in relation to patient records in the healthcare system. What can be done about these things? I mean, is fully private network appropriate in situations like that, where people would not use the public internet for linking sites, for instance? Is that a realistic thing to think about?
So, this is the field that I've been in for obviously a long time, and in fact, I actually back in the 90s, I worked on the government military side of things, where we had air gap networks, right? That was the name of it, where in fact, we had multiple air gap networks where you were either on a network or you were physically plugging into it. Otherwise, there was no other way to get onto get to the data, right? And that works if you can control the pipes end to end, and they're actually private pipes. But this is where the feasibility comes into the mix, and the costs, right? So to actually own your own fiber, to make sure that your fiber is protected, to have that fiber be available, and then it's a closed, what they call the hermetic ecosystem, right? And there are hermetic ecosystems out there still today, because the cost of a breach is just too high, right? And you can also afford to have that. That's you could say in a hospital, as long as with telemedicine, there are private lines that even as private as they can be for doctors, let's say, that are operating remotely, and a Da Vinci system, because and that end-to-end system is private and controlled and hermetic, right? There's no Google data centers involved in there, none of that stuff. So if a life is at stake, then and latency has to be, milliseconds of latency matter, because if you want to do a remote operation and you get a couple of packets dropping and you cut the wrong thing, then obviously that's not a good thing. But in general, if you expand that out to the general population, general workloads, I think affordability comes into play. The other aspect is that systems are not closed like that. You do need interconnect. In fact, one of the major requirements, right? So I always go back to the requirements, is all the third-party relationships that exist, right? Nobody manufactures everything on their own, right? There's all of these systems that need to interoperate today, and because of that interoperability requirements, then the necessity is that the systems have to be open, they have to be interconnected, and then the security has to be layered in. So ideally, you can say, hey, I don't talk to anybody, but that's just not the world today. And so to be able to operate in today's environment, to gain that agility, to have that globalization, it is essentially a necessity to have open infrastructure, at which point then security systems need to be layered in for prevention, for detection, for mitigation and response. And that's why cybersecurity space is such a big space, because there is a need for this level of interoperability and openness.
I think physical security also needs to be borne in mind as well, Michael. When you look at the remote sites, you need to be able to protect the asset that's gathering this information, that's processing the information. So that there's ways around that as well, where you can actually have the assets in a self-contained kind of edge physical rack, and that can be powered, cooled, locked, and also managed remotely as well, So you need to actually physically protect that, because you don't want maybe a disgruntled employee going out inside, taking the server, that network device or that storage device under his arm and heading off into the sunset. So you can actually physically manage and control the actual asset as well. There's an IT vendor actually today that have brought out an edge server, and if it's actually tampered with, it self-destructs. You know, there's that type of stuff that's actually now in the marketplace today. So physical security needs to be also borne in mind to protect the edge device or the edge infrastructure.
Great. So and also there's a saying when it comes to security, you should secure the message, not the network. So if we're using a public network, we have to secure the content better, rather than locking down the network when we can't lock down the network. So I think that, as you mentioned, Koroush, there are certain, probably fairly rare instances of isolated networks, and there used to be X25 networks and things like that were really expensive but fully known and governed and controlled. So I guess everybody is exposed by using the internet as the medium, in which case your option is secure physical data centers and cryptography then when it comes to the data, bearing in mind that there's a trade-off there with speed, obviously. Great. So anyway, so I think when it comes to edge computing, there will continue to be growth in the area. Security and the other factors that you mentioned, Koroush, in particular, latency and volume data and things at the volume of data need to be borne in mind. Just one final question for me then. In the context of skills and training and education in the edge computing market, where is the need? Is it to do with cloud technologies, or is it IoT? Is it business process, or a mixture of those things?
Marcus, maybe you want to take that. I wanted to also add additional topic here as to when people think about edge compute, what they should be thinking about, right, as part of that. But Marcus, I'll go after you as soon as you answer that other question.
I think it's important to ensure that people are aware and educated of the capabilities of edge infrastructure. It shouldn't be seen as a separate, maybe I suppose, division within IT. It's just probably what's like a smaller form factor of what's happening within the data center itself. So it shouldn't be seen as maybe a new I suppose aspect of IT. It really is all encompassing into what's there already. It's just really is a smaller, faster remote site of what's larger there already today in a cloud environment. So I don't think there's too much real education to be done there, in effect, outside of what's there today, Michael. But it is important that people are aware of the capabilities. I think Gartner have mentioned that in 5 years' time, we're going to see 75% of all data coming from the edge. So it's important that people can understand the strength and the power and what it can deliver as well. But I don't see any kind of revolutionary education or training to be provided. It's the same processes and same protocols as what's happened in mainstream IT, I think, really.
Yeah, the topic that I wanted to just to leave with the audience before we part is essentially the 5 tenets that I think about when I build a product. And it's, as a product guy, you're essentially the voice of the customer, right? So it's about understanding what the pain points are, what the customer needs to purchase. And so I wanted to, and then when you build a product, you want to be able to address that, right? So I actually have a slide that I've always used for a number of years, and I don't know, I can't share the slides on this at this moment, but it's basically these 5 areas, 5 S's that I use when somebody's looking to make a decision, and it's about finding a solution first that's simple, right? So I think simplicity is key. It goes back to the question that you're asking when you're trying to have people work with a solution from a training perspective. It just needs to be simple. But simplicity is about simple to buy, simple to deploy, simple to manage, simple to troubleshoot, right? So it's simplicity across the board. So I think that's one of the key criterias that, and each one has a lot of depth to it, right? So it means probably a lot of tools to be simple to manage. It means a lot of orchestration capabilities such that you can deploy where your job is simple, but what you're actually accomplishing is complex, right? So that's under simplicity category. Security, we already talked about it. So that's the other second S that I always make sure that it's in there. Security from threat engine, from secure boot, from securing data at rest, from securing the message, right? So the whole security tenant that needs to live across all the way from the platform that is chosen to the software engines that are on top to the way that the communication is done. The other S is sensible solution, right? So sensibility is about cost, is about making sure you have all the right parts to the equation, and you're not really compromising when you're making a product selection, right? You're able to really accomplish things, not overpay, but also not cut corners either, because because the solution just doesn't offer the choice. And then the other two that I think actually are quite important, and usually people don't talk about it. One is about sustainability, right? That's the fourth S. So it's about picking a platform that allows it to sit in operation for a number of years, right? Because these edge locations, there are many of them. You need to make sure that the software is upgradable. Even let's say you're using out-of-band modems and such, that technology is upgradable. Even the service stack on top is upgradable, right? So that you have a sustainable edge infrastructure in place that you can doesn't become obsolete and forces a forklift upgrade. And that last S that usually is the hardest one is a scale, right? You want to be able to do this, million nodes, right? People don't generally do million nodes, but if you want to deploy lots of edges, you want to deploy lots of devices and infrastructure that you're managing, very quickly it actually goes beyond 10, 100, and even 1,000, and you're in the tens of thousands of nodes. So having a solution that's been architected to scale, I think is and actually delivers that, I think is another aspect of the solution. So hopefully that's of value.
Absolutely. Koroush, Marcus, thank you very much. We're at the end of our time. That was a very interesting discussion. I wish we had a little bit more time. But for those of you who are watching this discussion, thank you very much for joining us. You can follow up with us on hashtag DTS21 and get in touch with ZP or Rahi respectively. Again, thank you very much indeed to Koroush and Marcus for a very useful and comprehensive discussion today.
Thanks, Michael.
Pleasure.